All right, let's check how you did. For this one, the answer is 6 root 2 in simplified form. How you got to that, the simplest way to get to that would be to say square root of 72 is the square root of 36 times the square root of 2, which is equal to 6 root 2. That would be the simplest way of getting to that answer. If you took the longer route, it is not wrong. Here is the longer route here. You saw that 72 was 9 times 8, and the square root of 9 is 3. But then you'd have to recognize that square root of 8 is 4 times 2, and the square root of 4 is 2, and 2 times 3 would make a 6 out in front. So whether you did it the green way or the purple way, you still get 6 root 2, which is the right answer. Okay? The second one, the answer is 2 cube root of 4. Now with cube roots, you're looking for a perfect cube that divides 32. 32, so the work that you would have probably showed to get this is you would have had cube root of 8 times the cube root of 4. 8 times 4 is 32, and the cube root of 8 is 2. So we have to write that little 3 to show that it's a cube root all the way through. For the third one, the answer is 2 fourth root of 3. How do you get that answer? Well, now we're looking for a perfect power of 4 that multiplies to get 48. 16 times 3 is 48. The fourth root of 16 is 2 because 2 times 2 times 2 times 2 is 16. And finally, the square root of 30 simplified is the square root of 30. You can't divide it by 4 nicely. You can't divide it by 9. You can't divide it by 16. You can't divide it by 25. And then the next perfect square is 36, which is already bigger than 30. So if you check all of the perfect squares, none of them divide 30. And so we would say that the square root of 30 is already simplified. So one of the things we do mathematically is we simplify. And later on, okay, I'm not teaching you this right now, but later on it might help us figure out. Remember, here I'll do a new screen. Remember the other day that I said the square root of 2 plus the square root of 8 was equal to the square root of 18? Later on, simplifying might help explain why this works. Can you simplify any of those? Right? Because right now, if I show you that 2 plus 8 equals 18, you're like, Mr. JR, this is not, math is really not making sense to me now. Like, it was bad before, but now you're telling me that 2 plus 8 is 18, and I want to just go home and have a long weekend and not think about math. But now you made the test on Monday, so you ruined my weekend, and things are bad. Okay. Well, maybe if we could simplify these things, maybe this makes a little bit more sense. Can you simplify the square root of 2? No. That one would stay square root of 2. Can you simplify the square root of 8? Yes. What would it be equal to? Square root of 4 times square root of 2. I'll do that small here. And then that would equal 2 root 2's. What about square root of 18? Can you simplify the square root of 18? It's 9 times 2. So can you see that it would equal 3 square root of 2's? And so when I say 8 plus 2 is 18, blah, but if I say 1 root 2 plus 2 root 2's equals 3 root 2's, does that sound like it's a reasonable thing to talk about? Okay? Now, you're not supposed to learn that yet, so if that made sense, just forget about it and pretend it never happened. That's next semester. Da-da-da-da-da. Okay. So for that reason, we like to simplify. You're going to see later simplifying helps us with adding. Okay? But sometimes we like to write things from mixed radicals as entire radicals. Because if I ask you what's bigger, 7 root 3's or 6 root 4's, it might be hard to tell. But if we look at 7 root 3's, 7 root 3's is the same as the square root of what times root 3? 49. And then 49 times 3 is the square root of 147. What did I ask you? Which was bigger, 7 root 3's or 6 root 4's? Well, let's do 6 root 4's just for fun. 6 root 4 is equal to what would go in that first square root? 36. And 36 times 4, 144. Well, 6 root 4's is actually 12, right? Can you see that the square root of 144 is 12? And could you see that you could have changed the square root of 4 to 2 and got 12 that way? But when we're asking which one is bigger, 7 root 3's or 6 root 4's, when you look at these two numbers, if I asked you which is bigger, the square root of 147 or the square root of 144, now does it become obvious that this one is the bigger one? And so changing things from mixed radicals to entire radicals is sometimes helpful for comparing which one's bigger and which one's smaller. Ooh, we want to write this one as an entire radical, and it's a cube root. So we would say, I need to write cube root of something times the cube root of 4. What goes in that first space? It has to be 8, because the cube root of 8 is 2. And now this becomes the cube root of 32. Our first question with a 5th root. So exciting. So we need to change the 2 into the 5th root of something, and then we have the 5th root of 3. 5th root of what is 2? It's a lot of multiplying by 2's, right? Yes. It's going to be 32. How can you check that? Well, 2 times 2 times 2 times 2 times 2 is 32. Now, I'm going to give you some time today to work on this, but before we work on this, I wanted to talk a little bit more about simplifying. In particular, the one that we had, the 4th root of 128, and I'm going to give you some more challenging ones after that, because they do get more challenging. Now, with the 4th root of 128, one of the things that I said at the end of last class is there's a way that you can use prime factorization to help you with these. So if we take a look at 128, it's 2 times 64 which is 8 times 8, which maybe you cheat a little bit in your prime factorization and do something like that. So 128 is the same as 2 times 2 times 2 times 2 times 2 times 2 times 2, which means I could write this as 2 times 2 times 2 times 2 times 2 times 2 times 2. How does that help us? Well, a fourth root, because we're dealing with a fourth root, says that if you have 4 of the same thing, the fourth root of that will be whatever that thing is. So I have 4 2's there. The fourth root of 4 2's would be 2. I mean, I could make this longer, and I would suggest eventually not doing this step, but I could put those 4 of them together and then have the other 3 that are left. The answer to this part is just 2, and this part is 8. So simplifying that becomes 2 fourth root of 8. How did we do this last time when we did our notes? Just as a review before I get to your question. We knew one of the fourth roots that we knew was 16, and we figured out that 16 times 8 was 128. Okay? But for most of you, you do not have your 16 times table, like, that's not one of the ones that you know well. So when you see 108, you're not like, oh, 16 times 8, yeah, I know that so well. No, that's not one of the ones we know well. So sometimes other strategies might help us if we can't see 16 times 8 right away is 108. 128, yes.
Is that factoring thing with like 6 3?
Yeah, with anyone you would like. So as a practice, we're going to add some more difficult questions. So let's say I did the cube root, okay, of how big of a number do you want? Like 432? Sure. 432. Let's add some variables. How many variables do you want? 3. X to the 5, y to the 7, and z to the 9. Beautiful. So first of all, let's figure out what 432 is, because that's probably not in your normal times table, right? So in my normal timetable, so I'm going to go to 432. It's 2 times 216, which is 2 times 108, which is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. Whew. So I have the cube root of, if I wrote 432 as its prime factorization, can you see that you have 2 times 2 times 2 times 2 times 3 times 3 times 3? Okay? All right, if I make that small now? Because I am going to need some space. What does x to the 5 mean? Okay. Thanks for picking 9. Thanks a lot. All right. What does y to the 7 mean? 1, 2, 3, 4, 5, 6. And then 9. And what does a cube root do? It means whenever you have 3 of something, you would be able to pull one of them out. So in other words, if I circle these 3 2's, I could pull out 1 2, because this would be the cube root of 8, and cube root of 8 would be just 2. And then I have 3 3's, which would be 27, and the cube root of 27 I could pull out a 3. Does this make sense? The nice thing with variables is you can see the variables quite easily this way. I'll switch colors to green with the variables. Do I have a group of 3 x's? Yes. Do I have another group of 3 x's? No. Do I have a group of 3 y's? Yes. Oh, I have another group of 3 y's. And then I have 1 left. And then finally, with the z's, I have a group of 3 z's, another group of 3 z's, another group of 3 z's. You can pull out multiple groups. So what happens when I pull out a 2 and a 3 in red? What number was going to be in front? 6. Okay. I go to my variables now. How many x's do I get to pull out? Just 1. How many y's do I pull out? 2 of them. Do I write that as 2y? No, because it would be y times y, which would be y squared. And then how many z's could I bring out? Z to the 3rd. What do we have left inside? 2x squared and a y. And this is simplified. With variables. So now, let's look first at the variables. When you're taking a cube root and you have an x to the 5, you could do the cube root of x cubed. That would pull out an x and leave you with 2 left in there. When you have y to the 7, it's a little bit harder to think that I could do the cube root of x cubed. That sometimes hurts our brain a little bit, but when we draw it out this way, you can see that I have 2 sets of 3 y's. I can pull out a y twice and would be left with 1 y that's left. And z to the 9, you can do the cube root of it perfectly. Does it make sense that z to the 9 is equal to z cubed times z cubed times z cubed? What's your exponent law for that? You add your exponents. Do you want to try one on your own? With variables. Here we go. Square root or cube root? Just a square root? Let's just do a square root. Okay? How about 405 inside? How about a to the 5, b to the 4, c cubed? How many people divided it by 3 first? Okay, and then did you get 135? And then 135 divided by 3 again, and you get 45. And that divided by 3 again, and you get 15. And that divided by 3 again, and you get 5. So we could rewrite this one as 3 times 3 times 3 times 3, 4 times 5. And if we wanted to, we go a times a times a times a times a. Oh my goodness. There we go. I thought I used smaller numbers, but there's still a lot of them. every time, since it's a square root, every time you have 2 of something, you could pull something out, right? Because here, this would be 9. What's the square root of 9? 3. 3 could come out. Here's another pair. Another 3 could come out. So when we look at our final answer here, we would have a 9 out in front. Looking at our variables, you would have an a squared out in front, a b squared out in front, and 1c. What's left inside of your square root? 5, a, and c. And this would be considered simplified. All right, so we're going to take the last 10 minutes to continue working on the homework from this section.